Good morning, everybody. Welcome to another fun-filled morning of Chem 1105 with your host, me, Dr. White. And I guarantee it will be a fun morning. All right. Now, let me remind you, tomorrow I will do my world famous review for the next test. Uh, you can find the slides I'll use are already in the lecture section near the bottom of Blackboard, but I'll do it live. Aren't you lucky? Uh-oh, it's being very awful bad humor day. But anyways, I'll be doing that. Friday, we'll have test number one. Test number one will be given during the Zoom lecture. What you'll do is you will download sometime, probably because of the high holiday on Thursday, I'll probably post it sometime Wednesday afternoon before sundown. I will post test number one PDF file. There'll be two versions, A and B, or whatever I call them. Half the class will take one, the other the other. They're almost identical, but they're not. That's cut down on cheating. And I do that face to face also. And Friday morning, about 5 minutes before class, about 10 or 9:55, I will send out emails to you, personally emails, with the password for your version that you should take. You'll take test number one, and then what I will do is you don't have to come to the Zoom meeting, but I'll hear your first 15 minutes and I'll check my email every 10 minutes during that time from 10 to 11:30. And if you have any questions, ask, because there's no such thing as a dumb question. And that applies also even during a test. Got a question? Ask it. I'm not going to give you answers to the questions, but if you have some concern or you're confused, I'll help you out. And you'll have until 11:30 Friday to take test number one and upload your answers to Blackboard in the assignment area, just like you've been doing the labs. Should be a single PDF file. Now, if you don't have a printer, don't worry. Just look at the PDF file on your computer screen, and on a piece of paper, bigger one than this, hopefully, you write down, don't write down the questions. You don't have to. Just write down the answers, problem one, your answer two, three, and so on. And then scan that or create a PDF file with your cell phone, and then actually my button's over here. But anyways, you'll upload that. And make sure for your upload, and I'll remind you again tomorrow, that you check your PDF file that you've answered or recorded all your answers in that file. Last semester, I had a couple of times, and luckily I was in a good mood, so I tracked them down. You never sent me page 7 of an 8-page test. That's a lot of points 2 students would have missed. And they sent it to me, but make sure you check. All right, let's get to work. Today, what we'll be doing is some balanced chemical equation practice time, and then I'll do a little more stuff from chapter 5, part 1, and then we'll have our lab. And today's lab will use Beyond Lab Z. It's fun. Trust me, I'm a chemist. Did that work? How about trust me, I'm a doctor. Did that work? All right. Yesterday, I was talking about the steps for balancing a chemical equation, and that means write the equation correct, which I'll give you. Determine if an equation is balanced on test 2. This is for test 2, remember. Don't forget, if I will be putting down at least 3 or 4 balanced chemical equations. If I ask you to balance a chemical equation, you're going to have to balance it. On my test and final, and they'll be on the final too, you will never, ever have to write down it's already balanced. That will never be the correct answer. Anyways, you balance the equation one element at a time, and check to see if the equation is balanced. But what I don't have on the slides, I'm going to share with you some super top secret methods of mine that I've developed that, Elena, 1 second, that I will share with you that makes it much easier to balance chemical equations. And one of your colleagues asked the question, in terms of writing it on an iPad, as long as you can write the answers to a question in a way I can read. That's important, because if I can't read it, I can't grade it. And you upload it as a PDF file, that's fine with me. Okay? Any way you can get into a PDF file the answers, do it, as long as I can read it. All right, let's go look at balancing chemical equations. Now, yesterday I showed you this equation. And thumbs up, people. You see what? Hydrogen, oxygen. Thank you. All right. Thank you, Mia. You got it first. All right. Now, notice on this side, I have one oxygen. Here I have two. It's not balanced. Now, students try and change the formula by doing that. That's wrong. You can't. But you can change the number in front called the coefficient. And the coefficient is always a whole number. Well, if I've got two oxygen here, and I'll put a dash so you know I'm not writing the number 20. How do I get two on this side? I put a 2 in front. So now I have two oxygen, but 2 times 2, 4 hydrogen. How do I get 4 hydrogen here? Put a 2 there. 2 times 2, 4 hydrogen. And now I always like to check 4 hydrogen, 2 oxygen, 2 oxygen, and it's balanced. And that's how you balance the equation. So let's have you try one. And on a test, I would write balance the following equations, 3 points each. Let me write that 3 nicer. Your turn. Balance the following equation. All right, I think everybody's done. Let's look at this. If we look at this, I have 1 magnesium, Mg. Here I have 3 magnesium. How do I get that to 3? I put a 3 in there. So now I have 3 magnesium. Here I have 2 nitrogen. Oh, look, I have 2 nitrogen. So is it balanced? And the answer is, let's find out. 3 magnesium, 2 nitrogen, 2 nitrogen. It's balanced. Now, this is an easier one. Let's look at one a little more challenging. And it's time to get a special top secret tip from Dr. White, how to balance the following chemical equation. By the way, this is called propane, C3H8. That's the gas or liquid in the white tanks for your barbecue. And when you react it with oxygen, you got CO2 water plus heat, which is how you cook meat on your barbecue. Now, listen carefully. Tip number one, or just tip, I'm not going to count them. When you're balancing chemical equations, leave hydrogen, oxygen last. You don't have to, but it makes your life a lot more easier, which is always a goal in my life. So if I look at this balanced equation, I'm going to do carbon first. Here I have 3 carbons. Here I only have 1. How do I make that 3? Put a 3 in there. So I now have 3 carbons. Next, all I have left is oxygen, hydrogen. So going this way, being lazy, I see hydrogen. I have 8 hydrogen. Oh no, I only have 2 here. How do I make that 8? Well, 4 times 2 is 8. So, whoops, there's 8 hydrogen. And all I have left now is oxygen. Here I have 2, but here I have 3 times, you have to count all the oxygens, 3 times 2, and I know that's 6 oxygen, and 4 times 1 is 4 oxygen, and that equals 10 oxygen. But over here, I only have 2. How do I get 10? I put a 5 there, and 5 times 2 is 10 oxygen. And now before I think I'm done, but before I say I'm done, I'm going to check. On this side, I have 3 carbons. On this side, I have 3 carbons. On this side, I have 8 hydrogen. On this side, I have 8 hydrogen. On this side, looking good, I have 10 oxygen. This side, I have 10 oxygen. Remember, count all the atoms and all the molecules on each side of each type. And that's how you do it. And trust me, you could have done starting with oxygen or hydrogen, but it would be a lot easier, like I did, starting with carbon and leave hydrogen, oxygen last. Your turn. C5H12 is called pentane. It's a minor component in gasoline, but it's used in other things. And why don't you balance that chemical equation? Have some fun. It is. And don't forget, it's National Tuesday Morning Turn on Your Webcam for Dr. White. Did that work? All right, I think everybody's done. Let's do this. How do you do this? Well, first of all, I'm going to follow my own advice. That's always a good thing. Leave hydrogen and carbon last. So hydrogen and oxygen last. So I have 5 carbon. Oh, I only have 1 here. How do I get to 5? I put a 5 there. I have 5 carbon. Well, next all I have is hydrogen and oxygen. So I'm going to go this way. Oh, I have 12 hydrogen. Oh, I only have 2 here. How do I get 12? Well, 2 goes into 12 6 times. For those who don't know your multiplication number tables, use your calculator. And therefore, 6 times 2, 12 hydrogen. And finally, here I have 2 oxygen here, but how many on this side? 5 times 2 in the first molecule is 10 oxygen, plus 6 times 1 is 6 oxygen. Add them together, 16 oxygen. Well, 2 goes into 16 8 times, and therefore 8 times 2 is 16 oxygen. And now, what do? You check and make sure you're done. 5 carbon, 5 carbon, 12 hydrogen, 12 hydrogen, 16 oxygen, 16 oxygen, success. All right, so remember, leave hydrogen, oxygen last. Now, a difficult type I call even odd balancing chemical equations. An example of that would be this. Take sulfur and oxygen, you get sulfur trioxide. That's the stinky stuff like you smell from eggs. But anyways, if you notice here, I have 2 oxygen. Here I have 3 oxygen. There's no whole number I can multiply 2 by to get 3. There's no whole number. Remember, the coefficients, the numbers in front of the compounds or chemicals in a balanced chemical equation are always whole numbers, exact numbers. Therefore, there's no way I can multiply 3 times a whole number and get 2. So what do? Why do I call this even odd? This side is even, this side is odd. So the trick I learned was multiply the 2 numbers together, 6. 2 goes into 6 3 times, and 3 goes into 6 2 times. And now let me clean up. When I've done that, I now have 3 times 2, which is 6 oxygen. I have 2 times 3, which is 6 oxygen. So it's balanced there. Notice now I have 2 sulfur. How do I get 2 sulfur? Put it there, 2 sulfur. And now I'll check 2 sulfur, 2 sulfur, 6 oxygen, 6 oxygen. This is even odd. If you don't know that, I call it a trick. You can be sitting here for a long time trying to figure it out. All right, your turn. Now, iron plus oxygen gives you ferric oxide, otherwise known as rust, which you don't want in your car anywhere else. But anyways, balance that chemical equation, please. Ooh, Dr. White's being polite today. All right, I think everybody's done, so let me get to work. Now, if we look at this, we see 2 oxygen on this side, 3 on this. This is an even, odd situation balancing chemical equations. And I know 2 times 3 is 6. So if I have 3 there, I'll have 6 oxygen. If I have 2 there, I have 6 oxygen. And now on this side, 2 times 4, I have 4 iron. And how do I get 4 iron here? Put a 4 there. And I have 4 iron, Fe. Am I done? Well, let's find out. 4 iron, 4 iron, 6 oxygen, 6 oxygen. Success, we did it. All right, let's try one a little more complex. I'm just checking to make sure I wrote it right. There's nothing more frustrating. I can't balance it. Well, you didn't write the right equation. That ruins your day real fast. And here's one for you to try. I would highly recommend try my first suggestion, leave hydrogen, oxygen last. Have fun. Remember, leave hydrogen, oxygen last is my tip for you. All right, I think everybody's done, so I better get to work. Let's see how we do this. Well, my advice is leave hydrogen, oxygen last, so I'm going to do aluminum. Here I have 1. Oh, here I have 2. So I'll do that. Next, hydrogen. Well, Dr. White says leave it last, so I'm going to follow his advice. Next, I see sulfur. I have one there, but 1 times 3 is 3 sulfur. So how do I get 3 sulfur on that side? Put a 3. So I now have 3 sulfur. And all I have left on this side is hydrogen and oxygen. So I'm going to do hydrogen first. 3 times 2, 6 hydrogen. Oh, I only have 2 here. How do I get that to 6? And by the way, write a 6 there. I put a 3 there. So now I have 3 times 2, 6 hydrogen. And all I have left is oxygen. 3 times 4 is 12 oxygen. And by the way, I forgot to write the 2 aluminum there. And this side, 4 times 3 is 12 oxygen. I think we might be done. Let's find out. 2 aluminum, 2 aluminum, 3 sulfur, 3 sulfur. Looking good. 6 hydrogen, 6 hydrogen. 12 oxygen, 12 oxygen. Success. Oh, that was fun. Let's do one more. And there you go. Have some more fun. This one's a little more tricky, but follow my advice. Leave hydrogen, oxygen last, and that will lead you to the right answer. All right, I think everybody's done, so I'm going to get to work and do my job. All right, how do you balance this? Well, I'm going to follow my advice. No, I'm not going to do hydrogen, but sulfur, I have one here, but here I have 1 times 3, 3 sulfur. How do I get 3 on this side? Put a 3 there. So now I have 3 sulfur. B is barium, boron, I'm sorry, boron. And I have 1 here, but over here I have 2 of them. How do I get 2 here? I put a 2 there. So now I have 2 boron. And next, I have left is hydrogen, oxygen. So I'm going to start here and do hydrogen. This is H2SO4, sulfuric acid. I have 3 times 2, 6 hydrogen. And in the second one, this is called boric acid. I have 1 times 3 times 2. So that would be 2 times 3 times 1, 6 hydrogen. And that adds up to 12 hydrogen. But on this side, no hydrogen there. In water, there are 2, but I need 12. So how do I get 12 hydrogens, atoms? 6 times 2, 12 hydrogen. And the only thing I have left is oxygen. 3 times 4 is 12 oxygen, plus 2 times 1 times 3, 1 times 3 times 2 is 6 oxygen. Added up together, 18 oxygen. Let's look on this side. Here, 4 times 3, 12 oxygen. 6 times 1, 6 oxygen. Added up together, it's 18 oxygen. I think we're done. Let's find out. 3 sulfur, 3 sulfur, 2 boron, 2 boron, 12 hydrogen, 12 hydrogen, 18 oxygen, 18 oxygen. Success, we did it. And that's how you balance chemical equation. And you are now an expert in balancing chemical equations. Remember, 2 things that I found helpful: leave hydrogen, oxygen last, and then also for the even odd, I taught you my personal trick. I call it a trick. You could call it a method if you want to sound more scientific, how to do that, and it works. All right, let's move on. And we've done our practice time. So what time is it? Oh, Dr. White's real happy. I am, because it's time to talk about the mole. Now, what is the mole? The mole isn't a furry little animal in chemistry that digs holes in the ground. What is the mole? The mole is the chemist counting unit. It's the counting unit used by chemists. Uh-oh, it's time for me to be subtle. First of all, you should know the mole is the chemist counting unit. Just like if you go to the supermarket and you want to get a dozen eggs, that's how they sell it, by the dozen. Well, instead of in chemistry, we don't use the dozen, we use the mole. And the mole is the chemist counting unit. Now, one definition of what a mole is something, a unit of something that contains 6.02 times 10 to the 23rd units. That could be molecules, atoms, it could be people. That'd be a lot of people. And this is named after Avogadro, a great Italian scientist. I think he did work before the term chemist was used. And his work was instrumental in understanding the mole. Now, the number 6.02 times 10 to the 23rd was actually discovered by 2 Germans, Why they weren't named after that, I don't know. I wasn't around then. But we call that Avogadro's number. Now, 6.02 times 10 to the 23rd, that's a large number. If you take 602 and then put 21 more zeros, that's huge. But this is our counting unit. It's time for me to share something very personal with you. And that is, one, my birthday is coming up end of December. Yay. And two, it's time for me to tell you what my all-time favorite birthday gift I would like. There's still plenty of time for you to save up for it. And that is, I would like a mold of pennies. It's just pennies, a whole mold of pennies. And if you figure that out, that'd be 100 million piles of pennies, and each pile was $1 billion. But if you want, you could write me a check to that amount too. That's probably more money that's ever been on this planet, the past, now, and in the future. That's 100 million billion dollars. The mole, Avogadro's number, is a huge number. But remember, December's coming, and all I want is a mole of pennies. Now, 1 mole equals 6.02 times 20 to the 23rd things. And what I'll be teaching you in the coming days, not Wednesday or Friday, but next week, is something that has been very useful to me. It's my good buddy, hold on, my good buddy, my good friend, unit analysis. I learned it in high school in AP chemistry. I had a great chemistry teacher who was also department chairman. I still remember his name, great guy, Mr. Ernest Salners, and he taught our class unit analysis. Actually, he beat it into our DNA to know that inside out. And you'll find unit analysis is your good buddy, your good friend. One thing I should warn you, between now and the end of the semester, I'm going to be going for the Guinness Book of World Record for saying your good buddy, your good friend, unit analysis the most times. Now, how does unit analysis work? First of all, if you have come on. A equals B. When you have one thing equal the other, you can have two ratios, A over B, and not equal, and B over A. And this is an important part of unit analysis. Whenever you have two things equal each other, you can have two ratios. Now, let's look at a simple thing. And this will be on a test of mine, but it gives you a start into unit analysis. Your good buddy, your good friend. Now, the first thing when I see a word problem, relax. I'll be showing you how to do word problems so they're not painful. They'll be fun. They will be. But anyways, they will be. I said so. First of all, what are you being asked to find? Well, how many eggs? What are you given? You have 3 dozen eggs. And what also do you know? 12 eggs equal 1 dozen eggs. And in the case of R, 1 mole equals Avogadro's number. So let's look, how do you begin? Well, there's only one number I have to work with, and that's that, 3 dozen. And if I had a magic ratio, something I could multiply it, two numbers, top and bottom, numerator and denominator, what units do I want my answer to be? Well, we figured that out, eggs. Now, here's how you use your good buddy, your good friend, unit analysis. I love that whistle. I'll try not to use it too much. Here's the heart of unit analysis. What numbers go here? Whatever you're trying to get to units wise goes on top of the ratio. Whatever we're trying to get rid of goes underneath the ratio. So if I take the time to just write in, I want eggs on top and dozen eggs on bottom. And where do I get these numbers? From this relationship. 12 eggs equals 1 dozen. Remember, you can have two ratios, this number over this or the other way. Now, if you notice, dozen eggs divided by dozen eggs, anything divided by itself equals the number 1. So this unit are left, are gone, and all I have is the right units, eggs. And 3 times 12 is 36, and that's how you do it. And that's unit analysis. Now, we're not going to be doing it with eggs. We're going to be doing it with, guess what? Molecules and atoms and other things I'll be teaching you. So, important thing to remember, 1 mole equals Avogadro's thing, Avogadro's number of things, 6.02 times 10 to the 23rd. Therefore, you have two ratios, this one and this one. Remember, A equals B. There are two ratios I can write, A over B and, not equal, and they're different, B over A. Now, in our class or in chemistry, the important thing is atoms and molecules. And here, 1 mole equals Avogadro's number, 6.02 times 10 to the 23rd atoms or molecules. And you have two ratios, atoms per molecule for 1 mole and 1 mole atoms per molecule. Now, what I don't have here, which I should have had, is the following. One mole of an element equals Avogadro's number of atoms of that element. 1 mole of a molecule or compound, like water, equals 6.02 times 10 to the 23rd molecules of that compound. Now, as I've mentioned before, a couple of years ago, I decided and thought about, am I testing people for chemistry in my test, or should I be testing them for chemistry and how good their memory is? And I decided No, I really shouldn't test their memory. This is a chemistry class. So these numbers I used to make students memorize will be important information test number 2, but you will have to know how to use that. If I look at my clock, it's time for a break. Let's take a break and then we'll come back and do the lab, and you'll get out early today. But you do that in lab days always when I teach lab. So come back at 9:50 and then we'll do today's lab. I'll see you in 5. I'm gonna get up and stretch. Time to get started. All right, everybody back? All right, let's get started. It's time for lab. And today's lab, don't forget to hand the lab we did last week sometime today. And today's lab deals with, let me get back to the top, detecting signs of a chemical change. And in a chemical reaction, when two or more substances are mixed together, new substance or substances are formed. How can you tell a chemical reaction has occurred? Well, it says simple, and it is. You'll see one of the following four signs in a mixture of substances. And these are, if you see a major color change, that doesn't mean it goes from dark blue to light blue. You see a real change in color, you have a chemical change. If you see a gas form, bubbles, another example of gas being formed. If you see a foam, foam is just trapped, there are a lot of bubbles all together, gas. Also, if you see a precipitate form, precipitate means a solid formed in a liquid. And you see little flakes of things. And I talked about this yesterday, and we can ask this both in lab and in the lecture. And finally, the last thing that you will, if you see, you know you've had a chemical change, is a change in temperature. The mixture gets hot or cold from where you started with. Well, in today's lab, you're going to be mixing things together to determine if a chemical change has occurred. Now, not all, there might be one where it doesn't occur. Would I do something like that? Of course. So remember, the four things, signs of a chemical change: major color change, gas form, meaning bubbles or foam, precipitate form, a new solid form, and a change in temperature. It gets hot or cold. If any one of these happens, you have had a chemical change occur. So in today's lab, what you'll do for mixtures 1 through 5, you will view the videos, YouTube videos listed below, and then you'll record your observation in table 1. Let's go to table 1. Table 1, here by different mixtures. Notice I have C note 1 below, and note 1 below is this YouTube, 2, 3, 4, and 5. And those are all the YouTube ones. And let's look at one. Oh, let's have some fun. All right, does everybody see YouTube on your screen? Thank you. Let's go full screen. I turned off the piano music. And this is sodium bicarbonate, bicarbonate of sodium and vinegar. No, you don't have to put the red food coloring in, which they will. And then you pour the vinegar into the baking powder. See all the bubbles form? Is that cool or is that cool? Now you know I'm a chemist if I'm getting all happy over this. And that's what you would do. And therefore, I'm going to help you out, so everybody should get this right. For mixture 1, when you took vinegar, which is mainly as water and acetic acid, and baking powder, sodium bicarbonate, what did you observe? And I hope you all put down bubbles or foam. So the question is, was there a chemical reaction? And the answer is yes, because you observe the following one of them, in this case, number 2. So that's the first 5. Let's look at 6 through 14. For this one, you're going to be using Beyond Lab Z. Log in, click on Chemistry for Higher Ed, and click on Inorganic. Now, this they since have changed it in the last couple of weeks, and I'm going to go through it. Essentially, it's the same thing. Everybody see Beyond Lab Z. And here's chemistry, and you don't have to click on both. And now I'm loading the inorganic. And here's the inorganic lab. Everybody see that? Now, first thing is you need a test tube in the test tube rack. Now you can grab it and pull it over, but an easier way, and Dr. White is lazy, you double click on the box. Watch over here when I double click. There's a test tube there, and these all light up. Now, if we go back to our lab, let's do number 6, silver plus and sodium chloride. So I'm going to click on the silver plus. Everybody see where my mouse is. And I click it, and you can see over on the right, contents, silver plus. Now, over here, you have various bottles underneath the shells of these cations. And here's sodium chloride. If I click on it, and look what happened in there. Do you see the white solid in there? Something happened. Now, I don't have it in the lab, but if you want to try, here's a centrifuge. And a centrifuge is like a washing machine in the sense that it turns real quick and it forces solids to the bottom. And if I click on this, look what happened. There's a solid at the bottom. And therefore, for the first number 6, did you see a solid form? And the answer is yes. So was there a chemical reaction between the silver plus and the sodium chloride? And the answer is, I'm giving away all the answers to the lab. Yes. And then now watch closely. It used to be you have to drag this test tube over to the waste, but this summer, they just in the last couple of weeks, they've come out with the new HTML. Everybody see the clear lab at the bottom of the center of the screen almost? Click on that, and you're ready for the next one. And what you got to do is double click and pick one of these and pick one of these and see if you see a color change or whatever. Now, unfortunately, I've been working with Beyond Lab Z to convince them to add some things. You don't see a gas formation or temperature change in this, which is why I did some of the YouTube for you. And that's today's lab. And what you have to do is, just like number 7, take the copper plus, add the ammonia, and look if you see one of the 4 signs. Now, I will give you a big hint. For 6, 7, 8, 9, and all the Beyond Lab Z, note 6 is do the experiment Beyond Lab Z. You will only see a color change or a precipitate solid. Because like I said, they haven't added yet bubbles, gas, or temperature change. And then at the back, at the bottom, I have questions. Now, notice question 1 says, which mixtures had a chemical change occur? Please use the mixture numbers. Don't write out, say, silver plus sodium chloride. It's easier for you, it's easier for me to grade. And notice I have a few questions, and that's it. And that's lab we'll do today. This lab is due next Tuesday. And don't forget to hand it in. And don't forget to hand in today the calorie of a nut lab. And with that, I'm done for today. I'll stick around if anybody has any last minute questions, but we've done our lab, we've done some chemistry, we've gotten some really good practice in balancing chemical equations. And with that, don't forget to study for Friday's test. I'll say, Gang gesund, goodbye.